Okay, guys. Um, for whatever reason, my dadgum video's not been working quite right, so I'm going to do this a third time. So let's get going. We're going to review standard form this morning. Standard form. Okay, in standard form, if you'll recall, is ax squared plus bx plus c. Okay, that is the standard form of a quadratic. Okay, A tells us a bunch and C tells us a bunch. And we use B to find even more, but these two tell us something right off the bat. If A is positive, and we write that, A greater than 0 means it's positive. Okay, then it opens up. And it looks like that. Okay, if A is negative, then it opens down. And it'll look like that. Okay, in vertex form notes, we talked about the vertex and the minimum and the maximum. Okay, two more things about A. If A, the absolute value of A, if the absolute value of A is greater than 1, then it is a vertical stretch, we say. We call it a vertical stretch. And what that means is that it goes up fast and it's skinnier. Remember, we talked in class about skinnier. Okay, so it'll be real skinny, like that. If the absolute value of A is less than 1, then it's a vertical, and it's not a stretch, it's a shrink. Okay, and that means it's wider, which means it's going to look flatter. It's going to go up slower. You see that? Okay, wider, skinnier. All right. C, okay, so we just covered A. So I like to highlight what we're talking about. Now we're going to talk about C. And when we talk about C, we have one thing to say. If I put in a 0 for x and a 0 for x, because if I let x be 0, it doesn't matter what A is, because 0 squared is 0 times A is 0. X is 0 times B is 0, so it's 0 plus C. Y-intercept. Okay, so C tells us right off the bat that it's the y-intercept. We'll write that as 0C. That means it's where the graph crosses the x-axis. So if my graph was like this, okay, that's the point we're talking about right there. Right where it crosses the x-axis, okay? No, y-axis. Okay, moving along. Every time you work with a quadratic, and we're going to do two examples down here in a moment, I want you to write A equals and write down the number. Whatever A is, it goes right there. B equals, and I want you to write down the number. C equals, and I want you to write down the number, including the sign. So if it's a plus, then it's a plus, okay? If this is negative, then there's a negative there, because that tells us a lot. Because then what we're going to do is we're going to use this to find the vertex, okay? So the vertex can be found in standard form by identifying these three numbers, and then we just write minus b over 2a, okay? That is the x value, and then we take that x value and we plug it into our function and crunch it out, and it gives us our y value, okay? So we have our x value and we have our y value. Every time this will work, okay? All of these things that we've been teaching you this semester are ways of evaluating quadratic functions. And in quadratic functions, what we want to know is where's the vertex. We want to know what's the y-intercept. We want to know what are the roots or the zeros or the x-intercepts, okay? What is the axis of symmetry, okay? One other note that I'm going to make here is the AOS, Okay, the axis of symmetry is always x equals minus b over 2a. Okay, so these are things that you want to make sure you remember. Okay, we're getting towards the end of our semester in Algebra 1, the end of our year in Algebra 1. But you're going to go on and take Algebra 2, and it's going to be really helpful if you remember all this stuff. Okay, so how are we going to use this stuff? I'm going to use all those things up there. So the first thing I told you is I want you to write down a equals, and if we look at this, there's nothing in front of the x squared. So it's a equals 1, and it's positive. That means it opens up. B equals negative 14 because there's a minus 14, and C equals 40 because it's plus 40. That also means that our y-intercept is 0, 40. Because if I put a 0 here and a 0 here, they go away, and that leaves me with 40. So when x is 0, y will be 40. So I'm going to just drop down here, and I'm going to write 0, 40. Okay? I'm going to switch over to pencil. And the first thing I'm going to do is I'm going to say, what is minus b over 2a? And I'm just going to take the minus b. So I put it out there in front, but it's like the opposite of b. Okay? Minus b is the opposite, same as the opposite of b. So the opposite of negative 14 is 14 over 2 times 1, which is 14 over 2, which is 7. So we know the first number of our vertex, the x value of our vertex, because up here we said minus b over 2a, okay, was the x value. There's my x value, okay? So here. Now, I'm going to plug in 7. And when I do that, I'm going to get 7 squared minus 14 times 7 plus 40, which is 49, plus 40 minus 98. Okay, what did I just do here? 7 squared is 49. I moved the 40 up here because I'm going to combine these two. And here, this is a 7, not a 2. It looks like a 7. 70 and 28 is 98. When I do multiplication in my head, I always do the 10s and then the 1s. So 7 times 10 is 70. 7 times 4 is 28. 70 and 28, 98. So this is 89 minus 98. Okay, and 89 minus 98 equals negative 9. That's this value. I just found my vertex. Now, up here in the green box, x equals minus b over 2a is my AOS, my axis of symmetry. So x equals 7. Done. Which way does it open? Up or down? We said it right up here at the beginning. As soon as I wrote down A, I wrote up. Opens up. All right, now, I want you to stop the video, and I want you to work B on your own, and then I want you to come back and see the answer, okay? See you in a minute. Okay, guys, if you did your work, you said A was negative 1, and it's going to open down. B is equal to 2, and C is equal to 9. The opposite of B over 2A is right here. The opposite of B is negative 2. 2 times negative 1, because A is negative 1, is negative 2 over negative 2, which is positive 1. So the first number of our vertex is 1. F of 1 means plug 1 in. Notice I use parentheses here, because up here it's the opposite of 1 square of x squared. So x is 1, and I get negative 1 when I square it. I get 1, but then I take the negative. 2 times 1 is 2, plus 9. Anyway, I get 10. I get 1, 10. My y-intercept is 0, 9. How do I know that? Because it's C, remember? And it opens down. Very good. All right, let's flip it over. Take a look at the back. Okay, now let's do a graphing. So I'm going to treat this the same way I did a minute ago. First thing I'm going to do is I'm going to take this and I'm going to write A equals negative 4, B equals negative 8, C equals negative 6, okay? It is going to open down. So right now I know my graph's going to look like that. That tells me a bunch. I also know that 0, -6 is my y-intercept. Okay? 0, -6 is my y-intercept. All right, I'm going to move that up just a little bit so I got it all on here. I already know that it opens down. This is usually my first thing I look at. I always want to know if it's going up or going down, opening up or opening down. So the next thing I'm going to do is minus b over 2a, which is positive 8 because b is -8, so the opposite is 8, over 2 times -4, which is 8, over -8, which is -1. All right, -1. X equals -1. Look at that. All I've done is minus b over 2a, and I found all this stuff. I've answered all these questions. Now what we're going to do is we're going to do f of -1. And that means I'm going to plug in -1. So -4 times -1 squared minus 8 times -1. Again this morning, minus 6. Okay? All right. So this is going to be positive 1 times -4 is -4. This is going to be plus 8. This is going to be minus 6. Okay? So -10 and 8 is -2. So my vertex is at -1, -2. Okay? All right. -1, -2. I'm going to use some color here to make life a little easier. -1, -2, right there. Okay? All right. Now, x-intercepts, and I've got a quadratic. What can I do? Well, I think 2 goes into all of those. I can try -2 times 2x squared minus 4x plus 3. This is a plus 4x, my bad. So -2 times positive 2 is -4. -2 times positive 4 is -8. -2 times positive 3 is -6. Okay, so I need to be able to factor this. Oh, please from. Can we get there from here? Yeah, we can get there from here. So -2, we're going to have a 2x. We're going to have an x. Okay, and we're going to have a 3 and a 1. There's only one way to do this, and that's with a 3 and a 1. So if I put a 3 here, I'm going to get 6x. No, I can't get there from here, can I? Nope. Okay. So it's not going to factor. But if we stop and think about it, it opens down. If it starts here and opens down, there are no x-intercepts. Okay, so I'm going to write none. So now I need some points. I like Sterling likes 3 minimum, but I really kind of like 5 when it is doable. 3 to 5 points. Okay. Well, here's something I know. I know -1. Okay, gives me -2. -1, 2, -2. Sorry. So that means I'm going to go backwards, -2 and -3, which means this is going to be 0 and this is going to be 1. I'm going to use 0, and I'm not going to work hard at this, guys. Here's what I'm going to do. And you can do this on your TI-30s. You can do it on your TI-84s, TI-83s. I'm just going to use my equation, and I'm going to put it in here with this x value. Okay? And then I'm going to go find my y value by hitting enter, and then I'll have these points, and then I'm going to reflect them using the axis of symmetry. Let's not forget about the axis of symmetry. Since my graph goes through -1, -2, I know that I have an axis of symmetry here, and it looks just like this. Okay, there's our axis of symmetry, and that is going to be x equal -1. That's our AOS. Our AOS helps us to reflect points over the axis of symmetry for easy graphing. So I'm going to use 5 points, but I'm only going to find 2 more. I've already got one. I'm going to find 2 more. Here's how I'm going to do it. I'm going to take my equation, and I'm going to use the negative key. Let me move this up. Let's see, can I get it up? Yeah, I'm going to use my negative key, and in most calculators, it's either the negative key or the minus. You have to check that out. But I'm going to go negative 4 times 0, and I'm going to plug a 0 in, and I'm going to square it because it's squared, if you look at it, minus 8 times 0, and I'm putting them in parentheses on purpose because I'm going to come back and do it again. I'm going to just hit enter now, and I get negative 6. So this is negative 6. My fingers aren't listening to my brain here. I almost wrote the wrong number, which means it's 0, negative 6, which means this guy is negative 2, negative 6. Here's what I mean by that. If I take my my highlighter, 0, 1, 2, 3, 4, 5, 6, right there. I can count 1 to the axis of symmetry and 1 there. By the way, see how skinny this is? A is 4. A makes it skinny. It's greater than 1. Okay? Now, I'm going to hit second enter on my calculator, and it brings everything back up on my screen. And I'm just going to go put in a 1. And I'm going to put in a 1. And because I'm going to do 1 now. And I'm going to hit enter, and I get negative 18. Now, that's off the graph. So what I know is 5 points. Even though I didn't graph them, I can put them on the test for Mr. Sterling. And I'm telling Mr. Sterling that I know what I'm doing. I'm using axis of symmetry, and I found 5 points. My graph is not staying on the graph, as you can see. So it goes real skinny. Zoom. Like sound effects. Zoom. There's our function right there. Okay? So now, further practice and review. What we want to do is convert this factored form into standard form. Okay? So this is intercept or factored form. Okay? We actually call it the intercept form, but it's factored. Okay? And the way we're going to do it is we're just going to expand. We're going to do the proper term in mathematics is binomial expansion. That's the proper term. You'll never remember that. So what do we say? FOIL or box method. Okay? Now, FOIL is first, outside, inside, last. You know me, I like Mr. FOIL. And so I'm just going to put a minus out here. Okay? And I'm going to go like this. 2x minus 3 times x plus 3. Okay? Now, I'm going to show you what I mean by Mr. FOIL. He's a unibrow, if you remember. 2x times x, 2x squared. Negative 3 times 3, minus 9. Okay? Down here for his nose, part of his nose, see the unibrow, see the nose. If I put a couple nostrils here, you can see the nose. Negative 3 times x is minus 3x. And 2x times 3 is 6x. Okay. Well, all right. Where is this taking me? Here's where it's taking me. I'm going to take this term, 2x squared, and I'm going to put my minus. It doesn't go away. It's got to tag along because we're going to do it at the end here. There's my first term. This is my last term. So first, okay, outside, inside, last. All right, FOIL. But what I like about Mr. FOIL is these two are right on top of each other and they're like terms. So 6x take away 3x is 3x minus 9. Okay? Final answer, negative 2x squared plus 3x minus 9. Okay? Now, this is our solution. Okay? This standard form is the same as that intercept form. They are the same function. But real quick, I want to just go like this and demonstrate quickly for those of you that like this box method and haven't used it in a while. There's going to be a minus out here, okay? I just go like this. And then what I do is I go 2x minus 3, x plus 5. These two together are 2x squared. These two together are minus 3x. These two together, did I have a bad? Oh, I see what I did. Ha. Mr. Sterling has a mistake. I'm talking and not paying attention. That's a 5, not a 10. It's a 5. So if that's a 5, then I get 10x here. This is 10x, which makes this 7x. Let's see what else that messes up. 3, oh, this is minus 15. Make this into a 15, because 3, so 2 times x is 2x squared. Negative 3 times 5 is negative 15. Negative 3 and 10. Okay, now this is a minus 15. And this is a minus 15, and this is a 7. Sorry about that, guys. You were probably yelling at the video. But good for you if you were, because you saw it. Now, that's fixed. So good thing I did it twice, because I caught my mistake. 2 times 5 is 10x, and 5 times negative 3 is minus 15. So here's what I like about this. Is I'm going to get a 2x squared, but there's a minus out here. So it's minus 2x squared, minus 2x squared. Can these guys right here always line up together in the diagonal? And this is why I like the box method, because it combines your like terms here. And this is why I like Mr. Foil, because it puts my like terms there. So 10 take away 3 is 7. And this should be a minus 7. It should be a minus 7. So this is 7x. Take away, change the sign is minus 7x. Good grief, I made some stupid mistakes here. Minus 15, so this is a plus 15. And this is a plus 15. Now we're good. Woo-wee. That was pretty ugly. But everybody makes mistakes, and it's also another good reason to always check your work, okay? Finally, last thing, we have vertex form. Okay, vertex form. Now, I want you to write it in standard form. Well, okay, what does that mean? Same kind of idea. So this, we're going to expand it, and we're going to combine like terms, and we're going to end up with this, ax plus bx, ax squared plus bx plus c, okay? So I'm going to go 2 times x minus 1 times x minus 1 minus 6, okay? All right, so once again, now I've written these proper. This square means take the base and multiply it times itself twice. So x times x is x squared. Negative 1 times negative 1 is positive 1. Negative x and negative x. So now we got 2 times x squared right here. These two together are minus 2x plus 1 minus 6. Order of operations, guys. That's all I'm doing. So now I'm going to take this 2 and I'm going to distribute it. Okay? So I'm going to get 2x squared, 2 times x squared. 2 times negative 2 is minus 4x. 2 times 1 is plus 2 minus 6. Final answer. Right here. Okay? Right here. I got to pause for a minute. Okay, guys. Why don't you try the box method on your own over here, then come back and check my work. Or check your work. Okay, all right, guys. So you get the same answer doing it 2 different ways. Okay, for Mr. Foil and box. So next week we're going to practice some completing the square. We're going to do some quadratic applications. We're going to start reviewing towards the end of the semester, starting next week. So all of our assignments will be on Math, Excel, and they will be reviewed. Thank you very much.